Hello, welcome to another episode of Computer Music Practice Examples. In this episode, we are going to talk about Many. It's an app that creates a quote-unquote infinite reverb, but it's more like kind of like an ambient sound generator. It takes in an audio file and it creates a very long sound and puts in and it generates a sequence of notes according to the scale that you choose. So if that does not sound familiar, please take a look at the link to app and the demo. And this episode will make much more sense. So we are going to create the app that is featured in the link video. So, like any other episodes in the CMPE, it is best to know about the terms that I'm going to be using in a block diagram, as well as the way I'm usually explaining. So, if this is your first time watching it, please take a look at the CMP introduction. And hopefully you are watching this with the Google slide that's coming with the in the website, as well as the if you know SuperCollider, with the SuperCollider file that's also being provided. So a little bit different from the other episode is that this app was made for a specific piece in a specific album. I need a certain sound for the upcoming album called Forms to Ponder, and I wanted to make a sound that uses this particular reverb technique. So let's hear the sound of what I really want to go for. Here is the excerpt from a track from my upcoming album, and it sounds like this. So you're going to hear the pad that's being generated right here. I wanted to create that kind of sound that generates the sequence of notes according to the pitch that I want to have. And you can hear that it's a long reverb basically, but it retains certain pitch characteristics. And because the source is pitch shifted, you actually hear certain sounds that's being in a certain kind of melody, right? So that's what we're going to make. And the process is relatively simpler than the other episodes. We are going to create a synthesizer and we are going to create a loop. We are not going to make a function for this episode. Also, we are still going to use a GUI to control the parameters, and some of the loops in the synthesizer will use some random number generators. Okay, good. So I should have put it here as a L instead of a function. But I'm going to use some random functions and control the parameters via GUI, and we are going to create a synthesizer and a loop. Okay, now we are going to dedicate a lot of time, most of the video, in explaining the instrument this time. So we are going to first create a synthesizer called Infinite Reverb, InfRev. And let's talk about the big picture first. We are going to create this sound. Okay. And generally it has a few parts. First, we need to play an audio file or read a buffer and play that. So you have a little sample player which is being controlled by an amplitude envelope. Okay, so you are going to create a little percussive sound using any kind of sound that's going in. And then we are going to make sure that the sound is turned into mono regardless of the number of channels that you have on the original sound. That sound will go through the reverb algorithm that we are going to talk about soon. And then that reverb sound will actually have a little amplitude envelope that will go like this, shoop, like that. So that way, if I have just a little a long uphill envelope for the amplitude, we are going to not hear the beginning. We are not going to hear the beginning of the sound, thus hopefully eliminating the transient characteristic of the incoming source. And what you're going to focus on is the tailed or the sustained part of the reverbed sound. Okay. Now we are also going to have a little silence detector. Basically, I'm going to create a little procedure so that when there's a silence that's longer than a few seconds, free up the memory. In SuperCollider and other similar programs, we have to manage the memory a little bit more carefully. So this is basically a way of detecting the end of the note and managing the memory so that the computer does not crash. Okay, so knowing this, let's focus on this part here, long reverb. Okay, and that's where you see this little dotted line going in. One way of making a reverb is creating a lot of delays, many delays. That's the name of this app come from. If you think about it, if you in a reverb is basically many echoes, a sound coming back, reflected from the surface. But we are talking about, if not thousands, almost like infinite number of sounds that's being reflected and coming back, thus having a delayed time. Okay, so we are going to try to simulate the situation by randomizing the delay time a little bit, and also randomizing the how long that the delay sound will last. Okay, but also most importantly, creating a little feedback algorithm. So what's gonna happen is that sound comes in and it gets delayed, and that delay signal will go back into the delay chain. And we're gonna do that for 7 times. Okay, and every time the sound gets fed back into the chain, we are going to have a different delay time and a different decay time, how long it lasts. But also, you are going to be able to control how much sound is going in terms of the amplitude. So we do that for 7 times, and you're gonna get many delays using one delay machine. So you're gonna get delay going in, and that delay gets delay, so you have a delay of delay. You do that again, and you get the delay of the delay of the delay, and delay of the delay of the delay of the delay, and you get the picture. So more repetition you do, you're gonna get more reflections, and usually that is controlled as the diffusion parameter in a lot of digital delays. Okay, so that is the main part of our instrument design, and after that we are going to go here, right? But know that all other parts like an amplitude envelope, the sample player, and a stereo to mono changer, we have discussed it in other episode of CMPE. We spent quite a bit of time in explaining the percussive envelope and the audio file player and how to detect mono and stereo files. So we are going to skip in explaining these 3 parts for the sake of time. Okay, and for the detecting the silence, there's one object that actually does all for SuperCollider. It's called detect silence. Basically, what I did was, if the sound goes in, and if the sound actually has silence, I think it's minus 60 dB for 2 seconds, free up the memory. Okay, so it's going to basically make me to prevent a computer from crashing. What we are going to do also is we're going to control 4 parameters. Actually 5 parameters. The rate of the audio file, so that we can control the speed of the playback, thus changing the pitch along with it. And also the general amplitude value, wet amp, and the delay time, the initial delay time, and then attack time of the sound itself. So here I have just one ramp attack, And by doing so again, we are going to try to eliminate the transient characteristic of the incoming sound. So we are going to control the attack time of that. And this one, A plus feed. We are going to actually create a positive feedback to create a longer lasting note. Okay, and we're gonna explain this in detail right now. So here is the supercollider code that you're gonna you can use. So in one of the supercollider packages that you downloaded, here is the step 1, and we hear this sound. Okay. Now you can try to change these parameters to create a different kind of sound. Okay. For example, here I can make my delay time like a little longer, and you can kind of create different kind of sounds. My rate could be slower, making a lower pitch. Okay. Now, before you go on and trying these patches and modifying it, I want to give you a little heads up. Be extremely careful with the parameter values, especially when you are dealing with the delays and feedback. Okay. For example, we cannot delay minus seconds. We cannot delay something that's minus value, right? You are playing certain sounds X seconds later. You're not gonna go back into time by putting like minus 2 seconds. Delay has to be a positive value, actually more than 0 usually. Okay, so do not go over 0 below for the delay time. Now, plus feedback, it means that whenever you go for the when you go through the feedback, so when you go through the loop, your value gets larger, right? And this value that we're talking about is the amplitude, meaning that if you are not being careful with the feedback value, you're gonna make a huge distortion. It's going to get very, very, very loud. Okay, so careful with it. Also, really try to hold your temptation to go like just put a minus number for the delay time. It's going to play the loudest sound possible for the computer to play. And if you have a headphone, that's gonna be not good. So do not. Yeah, I'm gonna give you a little warning to actually go for the value that's lower than 0 for delay time. At least do not use headphone. Okay. Good. All right. So let's actually talk about the values of this plus feedback and other things. So in reverb design, detail is everything. We made a loop that goes again and again for the 7 times, creating an X number of delays and totaling into a reverb. If you increase that, you can actually imagine that there are more reverbs and more delays, and it could create a rich reverb. So let's just hear that. So this is what I'm going to be using. So first tone sound is what I'm going to be using for the patch. Okay. And we get this much of kind of a long tail. Okay. So with the so you can see that everything else is the same other than that. Now this is without any iteration, and you can actually hear each individual delay time, 0.2 seconds. Okay, this is like having just like a few echoes when you speak into the room. Now this is 12 times being repeated. It's going to create the best sound and the longest lasting pad, but I choose to use 7, right? Because I'm gonna run this in here in supercollider. Now it uses almost like a peak of 3%. Let's do this again. Okay, about 2%. Okay, while if I just do 7, then it's gonna be around like a 1.5% or so, as opposed to this. One iteration. So this sounds better, but CPU usage is larger. Now I chose this because, as again, this is a top-down approach patch. I need to use this for a specific sound that I use for the composition, and I know that I'm gonna have a multiple of this instance. And we are talking about 20 or 30 instances at the same time at a certain point. Meaning that if I use too much of memory, then I'm going to crash the computer. Okay, so having a 7 iteration is a compromise just to make sure that my computer is not crashing when I use this pad. But perhaps I can use 12 iterations when my computer is faster. But for now, 7 sounds good enough. Okay, now I also have to make another compromise here. Not compromise, but a little adjustment. My plus A, A plus feed needs to be controlled carefully, because when you go for like a 7 iterations, it's basically you are going to the you multiply that by 7 times. So for example, if my A plus feed is valued is 0.08, then my amplitude will become 0.2. Yeah, right? Something less than 1, multiply again and again and again, it gets less. It's a negative feedback. But here, 1 to the 7 is 1, of course. But if I just increase 5%, and if I actually multiply that for 7 times by itself, check this out. My amplitude, which is 1, where 1 is the maximum volume, is already 1.5, 1.4. So if I'm not being careful, check this out, 1.3 to the 7th, I go way higher than what's being way higher than the maximum volume of the supercollider. So the last example you are going to hear, just to prevent the distortion that it's going to create, I'm going to just multiply by 0.3 so that it's actually, it's in a non-distortion range. Okay, so here, let's hear that. And you will see that if I actually make a kind of like a regular decreasing feedback value, then it's going to have, of course, small amplitude, but also my tail is gonna be quieter. I want this part, right? This part should be longer and presentable, audible, and by having a little bit of a positive feedback, this is the third one. Every iteration makes it louder so that I can actually get a little bit more sustained notes. That was my goal, have a longer sustained notes. Now this one, it will create the longest sustained value, but again, I may risk a distortion. Right now, you are not seeing any kind of distortion because the source itself is quieter, but if source is louder, then it could be quite loud. It could have a bigger waveform in here. Okay, good. So you can play this again on your side, but here are the examples of why certain details are need to be chosen for the sound that I want to. Okay, and you can also again change those values in here. Again, be very careful with this value and this value. Okay, good. So that is the instrument that we are going to create, a little infinite reverb. After that, we need to sequence them, and we are going to sequence it by using the loop. Okay, so we are going to use a loop function, and at every time we are going to repeat it, we are going to get the value from the global variable, and my loop function will interpret it and play a certain note at after certain seconds wait time using the parameter of a delay time, which plugs into the which plugs into the D time, and also over amplitude that goes to the A wet amp in here, and then the rate. Now the rate is where things get a little bit complicated. So the rate of the playback of the audio file determines the pitch, and we can get a specific interval by using by giving a specific ratio. So what this does is that I'm going to create just a group of the notes that I can create. So my sequence, my tilde sequence actually has 5 scales. First one is the major scale, second is the minor scale, third is the pentatonic scale, fourth is all the notes in a chromatic scale, so atonal, and then last one is the what I call the microtonal, because you're gonna pick any sounds that's between minus 0.15 steps to 0.15 steps, half steps. So what it does is that when I choose a which sequencer, this is what we are going to control. We are going to choose which scale to use, and then from that scale we are going to randomly choose a value. Okay, that's what dot choose does, and then that value will convert from a MIDI into the ratio and gets fed into the rate. So I'm going to choose a scale in MIDI value, a MIDI interval, and then that MIDI interval we get from that scale. I'm going to randomly choose a note, for example, like 2, and then the 2 will convert into the ratio so that my sound will, for example, go 2 half steps above the original sound. Okay, so combination of dot choose and dot MIDI ratio right here will determine the pitch relationship of the incoming sound compared to the original sound. Okay, so it's basically choosing an interval to create a kind of a major-ish color, minor-ish color, pentatonic color, and atonal and a microtonal sound. Okay, good. And you can actually look at that more detail in the supercollider code. Okay, and because of the design of the loop, we can change, for example, the value of the global variable to affect what's going on in the pad. For example, here I'm going to intentionally crash the sound. So instead of actually playing every sound at around wait time, okay, 12, I'm going to play this at every 0.5. So you're going to hear a lot of sounds. And there, I crashed it, right? So this is a poor memory management on my side, and the delays and reverbs needs to have a really good control on the memory for supercollider to not to crash. So we are going to prevent that, okay? And that's what we are going to do at here. Before I go back to the scale, go to the Google Slides. So if you want to see this contents of the scale, you can run this line. It actually shows you how major scale and minor scales are kind of created. So here, you know, this would be like if this was my original sound was a C, this would be a D, E flat, F, and a G, A flat, and a B, and a C in terms of half steps. Okay. Now, so we need to prevent some numbers to be entered by the user, and that's what dot clip does. For example, if I put a dot clip 0.1, 0.5, my delay time will only pass through if it is more than 0.1 and less than 0.5. If you put anything that's out of range, it's gonna go into either 0.1 or 0.5. Okay, so we're gonna put lots of dot clips in the in the GUI, but that way we basically prevent some possible errors. We are going to limit the choice for the users, and that's what's going to actually happen in GUI, the step 3. When you create a GUI, and basically each number box responds to the change in the number in the global variable. For example, here, changing the value in the max intervals is basically same as me doing this. Wait time 10 and run this code. Okay, so these 4 numbers, 3 numbers and a menu, a little bar, a little pull down menu is basically corresponds to these 4 global variables that we can control in a loop. Okay, now something that's actually quite interesting about the GUI is that once I have a GUI, I don't have to type in the number path for the audio file. So what I can do is I can just add in the sound from here to here by dragging it, and the next sound will actually create oops, I used MP3. I shouldn't use MP3. You can use all the WAV file only. Here I just drag in the cry, that wave, and the next note will actually use the other sample too. Or just drag it in, and every time the loop interprets the line, it's going to use the different audio file. Okay, and as I said, this is an infinite loop, meaning that as long as the computer is on and as long as the patch is on, it's gonna last without the definite time. Okay, and you can use this as almost like a kind of ambient pad. Okay, so here like this, a little bit more pleasing sound. Okay. And that is it. That is how GUI works, and you have the code and the diagrams to understand what's going on inside, and in terms of the design of the sound, and more specifically, design of the long reverb. Now, I've been using this term infinite reverb because I learned the basic concept of that from tagging Pierre Boulez's Anthems 2. A long time ago, I was tagging. I was doing the technical part of the on performing the this piece for the violin and computer with the director of the feature space. So, interesting thing about this piece is that the composer Boulez gives you what kind of electronic sound that he wants, but he does not provide you any program or hardware. It's tech person's job to create a sound that he's describing, for example, like an infinite reverb. So I made a little patch that kind of creates a very, very, very long reverb according to the composer's specification. And then for this one, I kind of modified it and actually added another feature to create a pad generator. So this was my inspiration and how I learned about this concept of infinite reverb. And feature space is a place where where I learned, where I had a gig. Basically, I got a gig to do this with the director of the feature space. It's located in Philadelphia, and I listed here because this is where I actually learn and practice a lot of things that I do this now. But I think it's a really good space, and when you visit Philadelphia, you're gonna see good shows in feature space. Now, for those of you who are relatively new to this series, the last page of the Google slide gives you a link to other CMPE projects and apps, and I'll be happy to answer questions if regarding any of this project or the many infinite loop generator. Lastly, by the time you're gonna watch this, you probably have this album Forms to Ponder released, and you're gonna see a lot of musical examples on how this patch and others were used to create an album. Actually, good. All right, I think that's it. Thank you for watching and listening, and I hope you enjoy using all the programs that's been presented in CMPE, including this infinite reverb machine. Thanks.